11.3 is about surface area of pyramids and cones. If we take a look at surface area is literally just lateral area plus the area of the base, like we talked about last section. Now, lateral area 1/2 perimeter times the slant height, L being the slant height, which is right there. Okay, same thing for a cone, lateral area plus area of the base. There's nothing different. Okay, where you can see it's still 1/2 perimeter times the base. What's the perimeter of a circle? It's just the circumference, which is 2 pi r. Okay, so if you look at problem 1, what's the surface area of the hexagonal pyramid? Now, this is a little bit different. You're still finding a lateral area, which is 1/2 perimeter of my base. Well, each side's 6. It's a regular hexagon, so every side's 6. And there's 6 sides in hexagons, because 6 times 6 is 36. Plus the slant height, which they give us, is 9. Okay, so that's going to end up, okay, and then giving us whatever that equals. We'll figure that out in a second. Plus 1/2. Now, to find the area of my base, it's a little bit different because it's not a regular square, rectangle, parallelogram, anything like that. It's this hexagon. So in order to do that, you have to have this formula, 1/2 of A times P, A being your apothem. I won't worry too much about how to find that, but they give it to us here, which is 3 radical 3. And the apothem just comes from the center point to one of the sides. So it's 1/2 of 3 radical 3 times, again, the perimeter, which that P is, and we know that to be 36. Multiply that all out, and you end up with about 255.5, okay, inches of squared for your surface area of this particular pyramid. Problem 2 is simply finding the lateral area of the pyramid. And again, we talked about lateral area being 1/2 perimeter base times your slant height. Okay, well, what's the perimeter of a base? Well, it looks to be a square here. It's 30 here, so all sides are going to be 30. So my perimeter is going to be 4 times 30, which is just 120. I need to find L. They don't give me L, so I'm going to blow this triangle up a little bit. They give us this is 36.4, and they tell me that the whole base of my pyramid here is 30. Okay, so if it's 30, what's half of that going to be? Well, it's going to be 15. We're looking for L. Well, looks like a right triangle. Looks like you have 2 sides of a right triangle. Screams Pythagorean theorem. L squared equals 36.4 squared plus 15 squared. Okay, take the square root of both sides. When you multiply and add it all out, you end up with 1,549.96. Now, I'm not going to take the square root yet because I don't want to round here and then round again. So what I'm going to do is plug this into my formula. So 1/2 perimeter of my base, which is 120, times my slant height, which I found to be the square root of 1549.96. And it says around a near square meter. So when I punch that all into my calculator, I get about 2,362 meters squared. Problem 3 talks about finding the surface area of the cone. Surface area is still lateral area plus area of the base, which is still sitting right here. Lateral area, again, guys, is still 1/2 perimeter of my base times my slant height. Well, the base is now a circle. So how do I find the perimeter of a circle? Well, it's just circumference. So it's 1/2 2 times pi times my r, which in this case is 15. Plus my bad, I forgot to throw my slant height in here, times 25, plus the area of my base, which is 15 squared times pi. And they want it in terms of pi, so I'm good. I don't need to hit that pi button. I kind of forget about it for a second here. But here, 1/2 times 2, those are going to cancel out. Or you could just straight punch in your calculator. 1/2 times 2 times 15 times 25 will give you 375 pi. And then 15 squared is 225 pi. Add them up. You get 600, and just stick the pi on the end of it.